Hello everyone, I'm Dr. Jahnavi Chakraborty, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In this video, today I am going to discuss the solution of algebraic and transcendental equations by Regula Falsi method. So now let us look at what is Regula Falsi method. This Regula Falsi method is also known as false position method. So first of all, we need to consider equation fx equal to 0. Then we need to choose 2 points A and B in such a way so that fa and fb are of opposite signs. That is, fa can be negative or fb be positive, or fb be negative, fa be positive, like that. Then we know that by intermediate value theorem, we know that there exists a root between A and B. Okay. So for our convenience, we are taking here FAB negative and FBB positive. Geometrically, this is equivalent to replace the y equal to fx function by the chord that passes through a comma f of a and b comma f of b. This is how it looks. So let us understand this by graphically. So now you take, this is y-axis and this is x-axis. This is x-axis and this is y-axis. Okay. You take a function, graph of a function that is in this way. Okay, this is the graph of a function. This is what? This is y equal to f of x. Okay. So now you need to take 2 values, right? You take 2 values on x-axis. One is, I am taking it here, this is a, and one I am taking it here, that is, okay, here, that is b. Now what is the function value of this a? What will be the function value of this a? So the function value will be lying here, right? So this point, let us denote it by a comma f of a. This is a comma f of a. So next, for this point b, where the function value will lie? Function value will lie somewhere here. Okay. So this I am denoting it by b comma f of b. Okay. So look at this y equal to f of x function. So it cuts x-axis, it intersects the x-axis at this point. So this point is the what? This point is the actual root. This point is the actual 0 or actual root. Okay, actual root. Fine. So now look at this. So here FA is lying in the 4th quadrant and FB is lying on the 1st quadrant. So FA is negative and FB is positive, and root lie between A and B. So what we do, next step, we connect this A and B point, okay, with a straight line. So connect this with a straight line. Fine. This straight line cuts x-axis at this point, and this point will be our first approximation. So this one is, let us denote it by x1. Okay, so let us denote it by x1. So now this is, what will be the function value at x1? The function value will be at x1 will be this one, right? This is what? This is x1 comma f of x1. This is f of x1. Okay. Now look at this f of x1. This is negative and fb is positive. So by intermediate value theorem, we know that root will lie between x1 and b. Okay, so how we will get the next approximation? So we need to join this f of x1 with this f of b again. So let us join this f of x1 with f of b. Okay, so now this line cuts x-axis at this point. So let us denote it x2, that is second approximation. Okay, so what will be the function value at x2? The function value at x2 is, this is x2 comma f of x2. This will be f of x2. Okay, now this f of x2 is negative and this f of b is positive. So root will lie between x2 and b. Next, what we need to do? Let us join this f of x2 with f of b. Okay, so we are joining this f of x2 with f of b. So it cuts x-axis at this point. Let us denote this point by x3. Okay, x3. So what will be the function value here? This will be x3 comma f of x3. Function value will be x3, f of x3. Okay, function value will be f of x3 here. So look at this. Likewise, we will get the next approximation x4, x5, x6, right? So we are approaching the actual root. Okay, so after certain iteration, we will approach the actual root. We will get the root nearer to this actual root. Okay, approximate root. So this is how Regula Falsi method works. So this is the graphical representation. Now let us see how we can represent it mathematically. So this is mathematically. So we know that a straight line passes through 2 points A and B. The equation of straight line passes through 2 points. What is it? So equation of chord passes through A comma f of A and B comma f of B is given by what it is? It is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. So this is y minus y1. What is y1 here? y1 is f of A. Okay, so what is y2 here? y2 is f of B minus f of A. y2 minus y1 by x2 minus x1, that is B minus A, into x minus x1. x1 is what? x1 is A. Okay, this is the equation of the chord. So let us give this equation number 1. So here, from here we know we have what we have. We have x equal to x1 at y equal to 0, right? X equal to x1 here, x equal to x1 where y is 0. So now put these values in equation number 1. So 1 will imply, what it will imply? Y is 0. So this will be minus f of A equal to f of B minus, this should be what? F of B minus f of A. So minus f of A, and it will be f of B minus f of A by B minus A and x equal to x1. So x1 minus A. Okay, so what you will get? x1 equal to A plus A f of A minus B f of A by FB minus FA. So you take LCM. what you will get, this is x1 equal to, you will get a f of b minus a f of a plus a f of a minus b f of a by f of b minus f of a. Okay, this a f of a will be cancelled out. So what you will get, this is the first approximation, you will get a f of b minus b f of a by fb minus fa. This is the first approximation. Now let us go back to yes. So here the equation of the chord I have already explained. This is y minus f of a, f of b minus f of a by b minus a, and into x minus a. So if the chord AB meets x-axis at x equal to x1, y equal to 0, then we get this first approximation as this one, that is a f of b minus b f of a by fb minus fa. So now we need to check what we need to check. We need to check at x1 what will be the function value. So if that function value f of x1 is 0, then we can say that this x1 is a root of fx equal to 0. So if this is, if in particular we are taking fx1 is positive, okay, in particular we are taking that fx1 is not 0, fx1 is positive. So if fx1 is positive, the root lies between a and x1, because we have f of a is negative and f of x1 is positive. So root will lie between a and x1 by intermediate value theorem. Then what will be the second approximation? The second approximation will be denoted by x2, and it will give a f of x1 minus x1 f of a by f of x1 minus f of a. So in place of b we need to put f of x1. Okay, in place of b we need to put x1 because the root lie between a and x1, right? So this is a f of x1 minus x1 f of a by f of x1 minus f of a. So next, if f of x2 is negative, so the root will lie between x1 and x2. Then the third approximation to the root will be denoted by x3, and it is given by x2 f of x1 minus x1 f of x2 by f of x1 minus f of x2, and so on. Likewise we get the fourth approximation onwards, we will get like this. Okay, this is the third approximation. Then likewise we can get the next approximation based on whether f of x3 is negative or positive. So now let us do one example on this method. So this is the question. What is given to you? A root of the equation x e power x minus 1 equal to 0. It lies in the interval 0.5 and 1. Determine these root correct to the 3 decimal places. This is the question. So how we solve this one? So this solution is, you need to take what is f of x. So let, what is f of x? F of x is x e power x minus 1. This is the f of x. Since this 0.5 and 1 is the interval, so what you will get for 0.5, f 0.5, so this 0.5 e power 0.5 minus 1, so what you will get? You will get minus 0.1756, that is a negative value. Okay, now you put what is b? B is 1. So f of 1. F of 1. So for f of 1, what you will get? This is 1 into e power 1 minus 1. That means e power e minus 1, right? So what is the value for this? 1.7183. That is greater than 0. Okay. Therefore, by intermediate value theorem, what we can say? A root lies between 0.5 and 1. Okay. So by method of false position, we are preparing a table. That is for first one, x equal to a f of b minus b f of a, fb minus fa. That is the approximate root. And this is f of x is given as x e power x minus 1, and last one is root lies between which interval? Negative, positive. Okay. So for the first one, first approximation, we have a as 0.5 and b as 1. Okay. So 0.5 into f of 1 minus 1 into f of 0.5 divided by f of 1 minus f of a. So we are getting 0.5464, this value. So now we need to check what will be the f of x1. Okay. So now f of x1 is f of 0.5464. So f of 0.5464, it is giving us negative value, that is minus 0.0564. Okay. So we know for f of 1 it was positive, and for this f of 0.5464 it is negative. So by intermediate value theorem, we get that the root lies between 0.5464 and 1. Likewise, we will get the other approximations also. Now you look at these other approximations, x2, x3, x4. Now you look at the other approximations, x2, x3, x4, x5 and x6. So for x2, we are getting x2 equal to 0.5608. So at 0.5608, the function gives us minus 0.0175. That is negative, right? So the root will lie between this 0.5608 and 1. Similarly, for x3, we are getting 0.5652, and at 0.5652, the function is giving us minus 0.0053, that is less than 0. So we are getting the root lies between this 0.5652 and 1. Next, x4 also, x5 also and x6 also, we are getting like this, that root is lying between this. For x5, the root is lies between 0.5670 and 1. Now look at this x5 and x6. So for x5, we are getting 0.5670, and for x6, we are getting 0.5671. So up to 3 decimal places, these two are giving the same value. So 5th approximation and 6th approximation, these two are giving this same value, that is 0.567. So the approximate root up to 3 decimal places will be 0.567. That is the answer. So what is the answer? Since x5 equal to x6 equal to 0.567 up to 3 decimal places. Therefore, what we get? Therefore, the required approximate root to the solution x equal to 0.567. So this is the answer of this problem. Thank you.